Hi, I am Madam Rosmaya. I am a physics teacher at SMJKUA Kajang, Selangor. And welcome to my YouTube channel. In this video, we are going to discuss the introduction of circular motion. So for first part, we are going to discuss on uniform circular motion. A body is in uniform circular motion if it moves in a circle with constant speed. Let's say v. At any instant, the direction of the velocity is tangential to the circle, which is perpendicular to the radius. Initially, at time t equals to 0, let's say the particle is at A. After a short time interval, delta t, the particle is at B. When the particle moves from A to B, the radius rotates through a small angle, delta theta. So this is the radius and delta theta. The angle delta theta is known as the angular displacement of the particle in the time interval delta t. The angular velocity omega of the particle is defined as the rate of change of angular displacement. Angular velocity omega is a vector quantity. In the time interval delta t, average angular velocity is given by omega equals to delta theta over delta t. Cross multiply, we get delta theta equals to omega delta t. Delta theta is angular displacement. For instantaneous angular velocity, omega equals to d theta over dt. So from omega equals to d theta over dt, we can cross multiply, get d theta equals to omega dt. And we take the integral both sides, so we'll get theta equals to omega t. The period t of the circular motion is time taken for the particle to move round a complete circle. So one complete circle, time taken for one complete circle is given by period t. Angular displacement for a complete circle is 2 pi radian. So the angular displacement for a complete circle is 2 pi radian. So substitute into the equation above. Theta equals to 2 pi radian and time taken for a complete circle is t period. So t equals to 2 pi per omega. The frequency f of a circular motion is the number of complete revolutions made in 1 second. F is given by 1 per t, and therefore t equals to 1 per f. So we substitute t equals to 1 per f into the equation. So we get omega equals to 2 pi f. The unit for frequency is Hertz. Okay, let's say the length of the arc AB here is given by delta S. From the definition of angle measured in radians, S equals to r theta. So we can write as delta theta equals to delta S per r. Or delta S equals to r delta theta. And for instantaneous displacement, we get ds equals to r d theta. So from this equation, we divide both sides by dt. So ds by dt is equals to the velocity. And d theta by dt is equals to angular velocity. So we have a relationship between v, velocity, and angular velocity, which is v equals to r omega. So the v is tangential to the circle. And this is for uniform circular motion. So that means the speed at any point on the circle is equals to V. Comparison between linear motion and circular motion. If in linear motion, we use displacement S. For angular motion, we use angular displacement theta. For linear motion, if we use time taken, circular motion also time taken t. If the linear motion, we use velocity v, and for circular motion, we use angular velocity omega. And the formula in linear motion, displacement equals to velocity times time. But for circular motion, we use angular displacement equals to angular velocity times time. So the unit for displacement is meter, whereas the unit for angular displacement is radian. The unit for time taken for both in linear motion and circular motion is the same, second. The unit for velocity is meter per second, whereas the unit for angular velocity is radian per second. Okay, one example. The length of the second arm of a clock is 1.5 centimeter. So what is the angular velocity and the speed of the tip of the arm? So first question, we are going to determine angular velocity, omega. So using equation omega equals to 2 pi f, and f is 1 per t. So one complete circle, the second arm made is 1 minute and equals to 60 seconds. So we substitute period here as 60 seconds. The answer is 0.104 radian per second. Next, we are going to determine the speed of the tip of the arm, v. So using the equation v equals to r omega, so radius of the second arm here is 1.5 centimeter, given in the question. So we substitute r and omega into the equation. So we get velocity equals to 1.56 times 10 to the power of -3 meter per second. Okay, that's all for the video, the end, and thank you for watching.